So this chamber behind me is called Lorentz. It's a low temperature chamber. So the idea is that you can put an antenna inside it and cool it down to very cold temperatures. It's the typical temperatures that you find when a satellite is actually in space. Today I'm involved in removing the flight hardware of the SWI instrument for JUICE. It's an RF instrument that's going to be looking at the atmospheres of the Jupiter and some of its moons. So normally we measure most antennas here at ESA in our Hertz facility. It's the big blue room that's seen in all our photos here. There you have the big blue spikes, and they absorb the radiation because you don't want any reflections when you're measuring your test. Because this instrument is on the outside of the JUICE spacecraft, it's going to get very cold when it's in the orbit around Jupiter. So we wanted to make sure that the performance of the instrument, we have the best knowledge possible that the instrument will perform when it's in this orbit. So this chamber will allow the instrument to get cold, and yet we can then still measure the RF properties of the instrument. So inside this chamber, the temperatures get down to about minus 180 Celsius. To get that cold, we have outside this building, we have some very large nitrogen tanks that hold about 25,000 litres of liquid nitrogen. And that gets pumped around the outside of the chamber, and that has the effect of it cools everything down inside it. So now we've finished this successful test. The instrument's taken out. They do an inspection to make sure that everything is okay, and then it will be going on now with a few final inspections back in Germany before it's then integrated onto the actual JUICE spacecraft. To get it out of the chamber, we have to use a crane to remove these large lids. Each lid is over a ton in weight. Well, now that we've successfully demonstrated this chamber works, this opens up a whole new world of opportunities for testing antennas and instruments in their representative environment. So there's hopefully lots of exciting tests coming up this chamber.
My name is Ali Ravanbakhsh. I am the AIVT manager of SWI Submillimetre wave instrument on board JUICE, and I work for Max Planck Institute of Solar System Research. So now the chamber is open, everything is at room temperature, but everything was very cold, Jupiter-like cryo temperatures for some days, and we hope that we got good results. It was a successful test thanks to the 24/7 support of ESA colleagues here at ESTEC. But we were anxiously also following everything remotely, the temperatures and the performance data. Everything went well. The instrument physically no damage and survived the test. And happy again to deal with it, to prepare it for the next tests.